Yes, students. Now I come to here to find the equation of simple harmonic motion. Every motion, like motion in a straight line, has its accelerated motion has equation. V equal to u plus at, s equal to ut plus half at square, and so on. Similarly, here this SHM simple harmonic motion has also some equation. Actually, different people uses the thing different way, and learner has many difficulties in learning the topics. Here I have taken a uniform circular motion, body moving on a circular path whose center lies at origin O in xy plane. The circle lies in xy plane and the center lies at origin of xy plane, and body move here with constant angular velocity omega. Let body start from point A at t equal to 0 and goes to B at time t equal to t. In this time interval, the angular displacement is theta. Now here, from point B, I have drawn perpendicular to P. This point P is called foot point or projection point. Please try to understand simple thing. Perpendicular from point B on YY diameter is called foot point or projection of point B. As body moves further, it come here, the foot point come here. When come, it will come here. When this way, and here, and here. So as body moves on circular path with uniform angular speed, then projection of this motion. Projection is you can call as a shadow. If here there is a point and this body object, and we draw line to the shadow of this at point P. If it is here, then light is drawn to the shadow in this point. So when body moves on a circular path with a uniform angular speed, then projection of the motion moves to and fro on any diameter. You can take projection here also, not only the YY plane. I will tell you something more. So, in figure, a body is moving on circular path with constant speed, angular speed, and the time taken to complete one vibration, one rotation, t equal to 2 pi upon omega, called is time period. So that way we can say that simple harmonic motion is the projection of uniform circular motion. From all this discussion, we can say here, we can say that projection of uniform circular motion, projection of uniform circular motion on any diameter, of circle is called, is simple harmonic motion. I have told you when body moves on circular path with constant speed and the shadow or foot point of B lies on P and moves to and fro. To find equation of SHM means to find how the displacement take place, how much is the velocity at any time, what will acceleration. So that is important here. So now to come to the equation, I start here. Let In figure, a body is moving with constant angular speed omega on circular path of radius, I take this radius as A, this is also A, radius A, and completes one rotation in time t equal to 2 pi upon omega. Here, now you understand t is the time period. Now, let body starts from point A at t equal to 0 and reaches a point B at t equal to t. The angular displacement of body in time t is theta, and hence theta equal to omega t. But the linear displacement of projection point along y dash diameter is y. Y is this linear displacement of projection point or projection of circular motion. P, foot point, was at origin when body was here and has gone to P. In this triangle OPB, in triangle OPB, dear learner, you are learner, may feel difficulty, you may feel difficulty, but things are simply, and I have taken this is theta, so this is perpendicular, this is hypotenuse. So from trigonometry, if this is theta, then theta, because transversal intersect parallel lines, these are parallel. So from trigonometry, y upon a is equal to sin theta. Y upon a is this radius, which is equal to hypotenuse, or y equal to a sin theta. But theta equal to omega t, therefore y equal to a sin omega t. Now see how omega determines value of y. You know, value of sin theta remains positive from 0 to 180. Derivation, please remember value of sin 30, sin 45, sin 60 and other angle. Try to understand how to see from log table. It is must. You can't pretend so how to understand. So now omega t. If omega t any theta 90, if theta any omega t equal to 90 degree, then y equal to a. If theta equal to omega t equal to 270 degree, ये यहाँ sin 270 minus 1, so then y will be minus a. इनके value of this y will keep on changing from 0 to plus a, then 0 minus a, and then so on. So the magnitude a, y equal to a, y equal to a means maximum displacement from equilibrium position. Is called amplitude of SHM. So dear friends, this is called A, amplitude, maximum displacement from equilibrium position. So our equation y equal to a sin omega t. Write equation 1 that, because I have so I have written like this. So this equation shows that as time so continuously changing, where body is moving, so when position changes we say body is in motion, and change in position vector for in time is called velocity. Please go to the chapter definition of velocity, position vector, acceleration. Here direction of position, this is position vector. Position vector. Direction depend on omega t. If omega t varies from 0 to 180, direction positive along position direction. Now, if omega t 180 to 360, it will be minus, y will be minus. So this omega t determine direction of displacement. तो इसलिए हम arrow we don't put arrow क्योंकि displacement vector है. Now there are some formula of differential. d upon dt of sin t is equal to cos t, or d upon dt of cos t minus sin t, and d upon dt of sin at. Suppose I write 80, so it will be a cos 80. A many number. d upon dt of cos 80, it will be minus a sin 80. I will use these formulae. मैं भाई इनको भी हमें यूज करना है. तो वेलोसिटी निकालना है, वेलोसिटी ऑफ एसएचएम, वेलोसिटी ऑफ एसएचएम. You know dr upon dt velocity. So here differentiating equation 1 with respect to time. we get velocity. I have explained you many times the meaning of this. So v equal to dy over dt, यानी कि d upon dt of a sin omega t is equal to a d upon dt of sin omega t. Or you can write here v equal to like this here a omega cos omega t, sorry, equation 2 of SHM. Velocity, if omega t is 0 degree, that is point P, that equilibrium point, then v equal to a omega. This is the maximum value of velocity of particle performing SHM. Actually SHM motion particle यहाँ projection point P के इसकी नहीं, this V maximum, and V maximum is also called as amplitude velocity और maximum velocity. लोग अलग अलग इस्तेमाल कर लेते हैं. मैक्सिमम वेलोसिटी, है भाई, मैक्सिमम वेलोसिटी ऑफ SHM. इक्वेशन 2 कैन आल्सो बी रिटन एज इक्वेशन 2. I write here v equal to a omega cos omega t, equation 2. We can write the other way also, as v equal to omega under root a square cos square omega t. स्क्वायर का जरूर ले दिया, और ओमेगा अंडर रूट a square into 1 minus cos sin square theta omega t. Or you can write a square minus a square sin square, but from equation 1 it is y square, so v equal to omega under root a square minus y square. This is equation 2 also again. You can write like this. Now from equation 2 you see v change with time t, omega 2 pi upon periodically different. So acceleration of motion, acceleration of SHM. Differentiating equation 2 with respect to time again, we get acceleration of SHM as alpha equal to dv over dt, or alpha equal to d upon dt of a omega cos omega t. It is a omega outside, d upon dt of cos omega t. How much it will be there? Sine cos minus, so alpha is equal to minus a omega square sine omega t. Equation 3. Y equal to a omega square. A sin omega t अभी बता y और alpha equal to minus omega square y. Omega is constant speed, so omega square constant, and hence since omega square is a constant value, so alpha proportional to minus y, which is the third characteristic, when magnitude of acceleration from magnitude of displacement, minus sign telling the direction and of acceleration, velocity, and displacement are opposite, means when displacement this way always measured from it, so the acceleration this way, opposite. If it body here point P, then y from negative will become positive. If I take direction left to right positive, so right to left negative. Here is the meaning. I have told many times. So these are three equations of motion. If here, y equal to a, yeah, theta 90, then alpha maximum होगा. Magnitude of alpha equal to omega square a. Magnitude. We will use it many times. I hope you may be understanding me, and please derive yourself and try to understand. I will take this circle here in case of SHM is called reference circle. I will take in the next video the same reference circle, but will tell you something other also. Thank you.